Good morning, or good afternoon, or good night, whenever you guys are watching this. How's it going, Trig? We just got done doing 4-6, which was graphing tangent, cotangent, secant, and cosecant. Some heavy stuff for sure. Got a little analytical for us, but we are moving on and moving ahead, and hopefully this one will make a little more sense because we're going to be dealing with something maybe you learned about and talked about in Algebra 2, and that's inverse functions. And before we get to inverse functions, inverse trig functions, I want to actually go back and review a little bit of your Algebra 2. What is a function? What is an inverse function? And then we can start applying some of those rules to sine and cosine and tangent. So that's the idea. Let's get after it. We'll do a couple videos, a little bit of a Nearpod, and we'll have a stamp to get some good practice with. So the first thing I am going to do is bring up a vending machine. I like to think of functions as a vending machine, basically because we have inputs and outputs, right? We have domain and we have range. Domain are all the things I'm allowed to plug into my function. That would be the numbers we hit in the vending machine. The range is what gets kicked out, all the possible things that get kicked out. So if I hit A, B, C, D2 over here, bloop, bloop, we go down to the D column, the second thing over, and it would kick out a water. Awesome. The next person comes behind me and says, you know what, that looked good. I'm going to hit D2 as well. D2, bloop, bloop, it kicks out the same water. It's a function. It's working. If the person behind me came up and hit D2, boop, boop, and it wasn't a water, then it wouldn't be a function. It kicked out an orange juice or whatever. It would be broken. Okay, and then that's not a function. What does that mean mathematically and graphically? Well, let's take a look at it, okay? Graphically, here is my vending machine. If I input a 2 or a 3, I guess if I drew 3, if I input a 3, it would kick out another 3. 3, 3. That's good. If the person behind me came up and put in a 3, it would still kick out a 3. It's working. This would be good. If I inserted a 10, it would kick out a 10. Awesome. That is a function. If for whatever reason my vending machine looked like this, a side opening parabola, it's not a function. I come in and I kick in a 3, and it kicks out a 5 in this case. Okay. The person behind me kicks in a 3, and it kicks out a -2, a -5. It's broken then. We should be getting the same thing. Okay. For every x value, there should only be one y value that gets kicked out. Sometimes you'll see them written as maps. This is my domain. This is my range. 1, 2, 3. 4, 5, 6. And then we connect them. Inputs with outputs. I put in a 1, I kick out a 4. I put in a 3, it kicks out a 6. That's okay. That is a function. If I added this arrow in there, think for a second. Is it still a function? Okay. I came in, I hit a 1, it kicked out a 4. Next person entered a 1, it kicked out a 6. Not a function. Broken. Okay. What about this map? 1, 2, 3. Is that a function? I hit a 1, it kicks out a 3. The person behind me inserts a 2, it kicks out a 3. We're still good there. That just means there's a lot of 3s. That would be the whole row of waters in our little vending machine exercise. It's okay. There can be a lot of waters in a vending machine. It still works. It's still a function. So that's our idea. That gives us what a function is. Now, the next thing we want to do is learn about what is called an inverse function. An inverse function, and I'll bring back up my vending machine, is I get a water kicked out. I don't want water, I lied. I want this little green chocolate bar. I think that's what it is. I decide I don't want it. So this is a magic vending machine. I can go put the magic chocolate bar back in and have it kick out what button I hit. So I'm giving it the output. I'm taking what it kicked out, I'm putting it back in, and I want to know what button got hit. Okay, that would be an inverse function. Okay, maybe there's a vending machine and then there's the evil twin brother vending machine right next to it that'll give you your money back or give you your input back, really. Okay, so back to those examples we had. If I have something like this, we're good. 1, 2, 3, maybe 1, 2. 2, 3, 2. I hit a 3, it kicks out a 2. Easy. Okay, but now we have this inverse function where maybe deeper. If I insert a 2, it needs to kick out a 3. Insert a 2, kick out a 3. This is the regular vending machine. This is the evil twin brother vending machine that's going to undo this stuff, and it's going to give me back what I started with. So I put in a 2, it kicked out a 3. It just switches the x and the y's. Let's look at some of our examples again. Let's go to this one. 1, 2, 3, 4, 5, 6. Would this have an evil twin vending machine brother? The answer, yes. If I plug in a 1, it kicks out a 4. The evil twin would have, I would insert a 4, it would kick out a 1. This is called a one-to-one function. 1, 2, 1. For every x I plug in, it kicks out exactly 1 y. And for every y, there's exactly 1 x. 1 to 1. That's good. That will have an inverse. Let's look at our example here that we said. The 1, 2, and the 3. Was it a function? Was it a good vending machine? Absolutely. But this time when I insert a 3, I want to know what my input was. I want to go backwards, but I don't know which one it came from. This one would not have an inverse. Okay, let's look at it like on a graph. Something like a parabola actually doesn't have an inverse. Okay, yes, it's a function. If I insert a 2, maybe it kicks out a -1. That's cool. But if I insert a -1, what is it going to kick out on my inverse? Because there's -1 twice. It's over here it's -1, and over here it's -1. So I wouldn't know what I insert. Did I put in a 2 to get this, or did I put in a -2 to get this? I don't know, okay? So originally, to wrap this up, and then we'll start using it a little bit. To be a function, it has to pass what's called the vertical line test. If it ever touches twice, my vertical line, it's not a function. If it only ever touches once, it is a function. Okay? To have an inverse, it has to pass what's called the horizontal line test, which is just kind of like the vertical line test backwards if you want to think of it. A straight line would pass the horizontal line test, and it does have an inverse. A parabola does not pass the horizontal line test, and it would not have an inverse. It touches twice. There is no vending machine that would take me back, would give me back what I started with. How about a cubic? That's y equals x cubed. Is it a function? Yes. Passes the vertical line test. Y equals x cubed, by the way. Does it have an inverse? Yes. It passes the horizontal line test. And the inverse would actually be y equals the cube root of x. Because if I plug in a 2 here, if I plug in a 2, it would kick out 2 cubed. 2 cubed is 8, and 8. The inverse, if I plugged in an 8, if I plugged in an 8 right here, what would it kick out? Well, the cube root of 8 is 2, back where I started. Okay, and that's what an inverse does. It takes whatever you started with, rips some math, and got that output. Takes that output, does the reverse math, and gives you back what you originally started with. Inverses. Moving on.